In this lesson, we are going to take rational expressions like the one shown here and simplify them in a way that is similar to the way in which we simplify regular fractions. So to begin, this particular expression can be simplified as follows, and we will look at how to do this shortly. First, however, I want to discuss what we mean when we say that these two rational expressions are equal. Well, this means that these two expressions will have the same evaluation for any value of x. So, for example, if we let x equal 2, we can evaluate both expressions by plugging 2 into both sides. When we evaluate each expression for x equals 2, each side evaluates to be 4. So when x equals 2, both expressions have the same value. The same holds true for any value of x. If we let x equal -5, we can evaluate both expressions to see that both sides here are equal to -3. In fact, for any value of x, these two rational expressions will have the same evaluation. The only difference between these two rational expressions is that the one on the right-hand side is written in simpler terms. Okay, now let's see how one goes about taking a rational expression and simplifying it. To do this, we must first factor the top and bottom completely. So we will begin by factoring out the greatest common divisor of the numerator. Here we can factor out a 6. Likewise, we can take the denominator and factor out a 2. At this point, we can take this quadratic polynomial and factor it to get x plus 6 times x minus 4. And this expression here is a difference of squares, so we can factor it to get x plus 4 times x minus 4. Now that we have completely factored the top and the bottom, we can simplify. First, notice that we can simplify 6 over 2 to be 3. Now notice that we have x minus 4 on the top and the bottom. Since any expression divided by itself always equals 1, these two expressions cancel out, leaving us with 3 times x plus 6 all over x plus 4. So we have now simplified the rational expression. Now some of you may have spotted a slight problem with this example. Earlier I said that these two rational expressions will have the same value for any value of x. That wasn't quite true. Sure, when x equals 2, the two expressions have the same value, and when x equals -5, the two expressions have the same value. But notice what happens when we let x equal 4. When we evaluate the two expressions for x equals 4, the expression on the left-hand side evaluates to be 0 over 0, and the expression on the right-hand side evaluates to be 30 over 8. So when x equals 4, the two expressions are not equal. So what happened here? To find out, let's go back to our earlier work. The problem is with this simplification right here. We said that x minus 4 over x minus 4 must equal 1. But is this true? Must it be the case that x minus 4 over x minus 4 is equal to 1? Well, when x equals 7, we can see that x minus 4 over x minus 4 does indeed evaluate to be 1. Similarly, when x equals -2, the expression evaluates to be 1. However, notice what happens when we let x equal 4. When x equals 4, we get 0 over 0, and 0 over 0 does not equal 1. So although x minus 4 over x minus 4 equals 1 for most values of x, it does not equal 1 when x equals 4. As such, we cannot say that these two expressions are equal for every possible value of x. What we can say is that they are equal for all values of x just as long as we do not let x equal 4. So if we prohibit x from equaling 4, then these two expressions are indeed equal. Now for the GRE, this point is of little consequence. When simplifying rational expressions, you will not be required to determine which values of x are prohibited. However, you will see provisos such as this one, and you may wonder why they are there. These provisos are here so that we maintain 100% mathematical correctness. However, you don't need to worry about them when writing the GRE. Now at this point, I need to make another confession. These two expressions are still not entirely equal, even if we prohibit x from equaling 4. There is also a problem with these two denominators. Notice that when x equals -4, both of these denominators evaluate to be 0, which means both expressions here have an undefined value. Since we cannot say that two undefined values are equal, these two expressions are not equal when x equals -4. So we need to add a second proviso that says x cannot equal -4. So we can see that these two expressions are equal for all values of x except when x equals 4 and x equals -4. Now on the GRE, a common way to handle this issue is to say that these two expressions are equal for all values of x for which both expressions are defined. Now if any of this is confusing to you, I should repeat what I said earlier. You do not need to worry about any of this when taking the GRE. Just know that occasionally GRE expressions will include additional pieces of information in order to maintain mathematical accuracy. They do not affect how we simplify rational expressions. Okay, let's try one more example. To simplify this, we will first factor out an x in the numerator, and we will factor out an x in the denominator. The quadratic polynomial on the top can be factored, and the quadratic polynomial on the bottom can be factored. At this point, we can simplify x over x to be 1, and we can simplify x plus 3 over x plus 3 to be 1 as well. This leaves us with x plus 1 over x minus 1. So we can say that these two expressions are equal for all values of x for which both expressions are defined. Okay, that concludes this lesson on simplifying rational expressions.